Alright, so hello again. So right now I'm on a production system. So this is that same quadratic optimal start equation. So when I'm installing this, I'm also installing it on someone else's Niagara system. So it's actually not a system that I set up. So it's actually like a really large VRF system. So it's a high school, about 100 VRF cassette units. So here we go. This is actually a wire sheet on one folder inside of the Daikin master station. So this is like what the points look like that the original contractor mapped through for the VRF. So I am going to paste in my stuff. So if I kind of slide it around, make it look nice and neat. So I'm also in imperial units, but if you're using, if you're not in the United States and you're using metric, just use all metric units. Just feed everything into this block, all metric. Don't worry about converting units from degrees Fahrenheit to metric, just feed in all metric. Okay, so I can see that this VRF system has like a set point here of 73, and they're doing some kind of deadband under the hood. So whatever they're doing, they're doing something here. Maybe they've gotten this VRF system to work this way, but I can see that they have some heating and cooling set points, and there's also this occupied start, or the start command. So I am just going to grab this cooling, feed it into mine, grab the heating, feed that into mine. So that, maybe I'll just move some of their points out of the way, clean it up a little bit. Alright, so that's actually calculating this target zone set point, and the temp tolerance of 2 degrees. So we have a schedule on this JACE already, so I'm actually going to delete that out. Delete out some of these notes. So this is actually a different folder on the station, so I'm just going to link mark the schedule and then link to this block from the schedule. So here's the next time, and then we have this slot here, schedule next time, and also link from the schedule again. So this will be schedule next value. Alright, so then we just have to, we also need to link in from the schedule again, the actual, actually, no we don't, sorry. Okay, so the only thing we have left to do is feed in a zone temp to our block. Alright, so where's the zone temp on here? Filter, alarm, blah blah, room temp. Feed you in there. So this is what I'm going to end up doing for each VRF cassette here in this school of 100 or more VRF cassettes. Paste in an optimal start block, and then I'm going to start linking away. So like right now we have the zone temp, target zone set point is calculated from here, and also our temp tolerance that is 2 degrees. So like what the optimal start block will do is start calculating how many minutes it'll take to get the zone temperature to within a temp tolerance of 2 degrees. And if we're within 2 degrees of the temp tolerance, this where are we here? So like we would actually see a minute calculations. So it doesn't look like I have that exposed. So we would be, we're continuously calculating to know like when the equipment will start or not. So, and we can optionally set trends up on this too. So I'm going to be watching these to verify that our block is doing what it should be doing. So what I am going to do now is actually, this is our target point, so I'm going to actually start you a little bit earlier. Alright, so hopefully that makes sense. Maybe I could even pull you over here for... This looks a little redundant, kind of looks like crap, but so basically our optimal start when it's not running will be a slightly higher priority than what their schedule is writing. So this is the normal BAS schedule, and then this is our optimal start block writing at a slightly higher priority, and then if it's not being utilized, it'll be null. Maybe I'll even clean this up a little bit. Whoops. Okay, so this will be our schedule start command. And yeah, that should be pretty much to it. So this is once again production environment, and yeah, lots of link marking, zone temp, target zone set point, temp tolerance, which is an extremely important parameter that doesn't matter if it's metric or imperial units, that the zone temperature, if the zone temperature is within temp tolerance of set point, this block does not do anything. And then we also always need to look at the schedule's next value and next schedule start time. So the next, so let's get into the Python side, and we can study, the theory running in here. So there's a lot of Java code in here. So it looks a little bit different than Python. Like it's, you have to declare data types, which is nice. You don't have to do that in Python. And a couple little characters, the end of the carriage. Java is this compiled language, which makes it kind of optimized for building automation, embedded devices. So it runs really smooth and efficiently because it's compiled, and we can compile it even here. Compared to Python, Python is not a compiled language. It's actually compiles at runtime. So yeah, this is optimal start, and then in the production environment, we should always be monitoring our resources too. As shown in the Vibe Coder repo, people have seen that these program objects burn up a lot of resources, but I haven't had any problems with it. As you can see on this JACE, there's 386 megabytes of heap memory available, and we have 228 of heap free memory. So it's got plenty of memory on this machine, on this JACE, and our CPU usage is really high. I just noticed that now. Maybe that's just because we did a compile or something, but our CPU usage should be consistently below 80%, which it looks like it was. I might have been doing something here to cause that, but it's important to watch for that too. So thank you for watching, and tomorrow let's get into these Python lessons. Have a good day.